Okay, now we're going to try to put everything together by solving multi-step inequalities and then graphing them. So if you want to try this by yourself first, you can pause the video. If not, we can work on this one together, and then there's another one for you to try after. So the problem is 2x minus 4 is greater than or equal to 4x minus 1. So if you remember from the last video, we want to bring our variables together first. So I'm going to subtract 4x on both sides to get my variables to one side. And let me show you what that looks like so you can follow it step by step. Minus 4x on this side. Okay, so on the right side, 4x minus 4x cancels out. And on the left side, 2x minus 4x is negative 2x. And then I have minus 4 is greater than or equal to negative 1. Okay, so now just like a two-step equation, we're going to add 4 to both sides. So when we do that, we get negative 2x is greater than or equal to 5. Okay, now we're going to divide by negative 2 on both sides. So if you remember from the last slide, or the last video in this case, when you divide by a negative to isolate the variable, the sign switches. So now I have x is less than or equal to, so I had to flip the direction of the sign, and 5 divided by negative 2 is negative 2.5. Okay, and now we're going to graph this. Okay, so you can choose whole numbers, you can choose, half number increments. It's totally up to you, but you have to label your number line first. So I'm going to make this negative 3, and then I'm going to go by halves. So here I have negative 2.5, and then here I would have negative 2. Then here I would have negative 1.5. I usually like to have at least 5 numbers on my number line. So I'm going to just add in one more, and then we'd have negative 1. Okay, now that my numbered line is numbered, I'm going to graph it. I need a closed circle because it's also equal to on negative 2.5. And because it's all numbers less than, I want to go in the direction towards the left. Okay. All right, let's try one more. Here we have a fraction. So hopefully you're a little bit more comfortable with them now from the last video. We have 1/3 times the quantity x plus 3 plus 1/2 is greater than negative 9/2. So the first thing you want to do is distribute the 1/3. You want to multiply it by x and by positive 3. So 1/3 times x is 1/3 x. 1/3 times 3 is 1. Then we have our plus 1/2 is greater than negative 9/2. Well, now we have to combine like terms. 1 plus 1/2. I use common denominators, so I rewrote 1 with the denominator of 2. So that would be 2 over 2. 2 over 2 is the same thing as 1. I just multiplied numerator and denominator by 2. So 1/3 x plus 2 over 2 plus 1/2 is greater than negative 9/2. So now I can add my 2 over 2 plus 1 over 2, giving me 3 over 2. 1/3 x plus 3 over 2 is greater than negative 9/2. Now I can subtract 3 over 2 from both sides. So minus 3 over 2 on this side and minus 3 over 2 on this side. Negative 9 over 2 minus 3 over 2 gives me negative 12 over 2. And now I have to divide by 1/3 on both sides. And remember, Dividing by 1/3 is the same thing. I have to rewrite it as multiplying by 3 over 1. Remember, I have to multiply by the reciprocal. So negative 12 over 2 times 3 over 1. Then you can multiply straight across. That gives you x is greater than negative 36 over 2, which is simplified to x is greater than negative 18. Now I didn't flip any signs here because when I isolated the variable, I divided by positive 1/3, and because it was positive, I did not need to flip the sign. So I have my number line numbered here. I have negative 19, negative 18, negative 16, negative 16, negative 15, and it would continue, but this is just a snapshot of my number line. I am going to draw an open circle on negative 18 because it does not include the number 18. It's all numbers greater than, so all numbers to the right of negative 18. Okay, now just like we looked at equations with no solution or infinite solution, the same thing happens with inequalities. So let's look at a quick example here. If I subtract 8n from both sides to bring my variables to one side, subtract it from here, that would cancel out. I'm going to do the same thing here. And you'll see that I'm left with negative 21 is greater than 0. Is negative 21 greater than 0? No, negative 21 is a lot less than 0. So this inequality does not make sense. We say no solution. You must write no solution, though, to answer the full question of what you solved for n in this case. There is no number you can substitute for n that would ever make this statement true. So the answer here is no solution. Now let's look at another example. We have negative 3n minus 2 is greater than negative 3n plus 20. So let's get our variables together first. Let's bring them to one side by adding 3n to both sides. Okay, now the variables on both sides cancel out. Negative 3n plus 3n is 0, and negative 3n plus 3n here is 0. So we are left with negative 2 is greater than 20. Okay, is negative 2 greater than 20? No, negative 2 is less than 20. So again, we have another no solution example. Now, if this answer were switched around, just so you know, if we had ended up with negative 2 is less than 20, how do you think we'd answer that question? Well, in that case, every number in the world would make that inequality true, so we would say infinite solutions. Okay, and finally, we're going to look at verbal expressions using inequalities to represent words, and then we're going to look at one word problem. So the winner of the tournament will win at least $5,000 in cash prizes, at least. So this is the key term here. So winner, I'm going to use the variable W to represent winner. Just use a darker color to make it a little easier to see. And I know that my solution is 5,000. So winner will win at least 5,000. Well, how do I say winner will have at least 5,000? Well, that means greater than, and in this case, at least includes 5,000, so it's also equal to. This means that the winner will have more than or equal to $5,000. Okay? And now to lose weight, most people need to eat at most 1,600 calories a day. So at most, think about what that means to you. Do you want to eat more than 1,600 calories, or do you want to eat less than that? So to lose weight, so people need to eat at most 1,600. So I know 1,600 is my solution here. but I don't want people to have more than 1600. We have to have it less than 1600. But can they have 1600 to lose weight? Yes, it says at most, so we can include the number 1600. It doesn't say just less than 1600. So P is less than or equal to 1600. Okay. Emily and Amy's super secret club is trying to raise money for a super secret activity. So far, they have raised $600. In order to make the rest of the money, they are planning on selling cupcakes with a super secret center filling for $2.50 each. Write and solve an inequality to find out how many cupcakes they need to sell in order to have at least $1,200 for their super secret activity. So we know that she already has $600, and then each additional cupcake with the secret filling is going to be $2.50 each, and we want to have at least $1,200. So if you remember in this verbal expression, at least, so we can have 1,200 or we want more than 1,200, but we definitely don't want less than that. So to write the inequality, we have 2.50x, okay, that's per cupcake, already have $600, and we want this to exceed 1,200. Okay, we want to have at least $1,200. So now we can subtract 600 on both sides, leaving us with $2.50 x is less than or equal to, in this case, 600. Then you're going to divide by 2.5 on both sides, and that 600 divided by 2.5 gives you x is greater than or equal to 240. So Emily and Amy need to sell at least 240 cupcakes in order to make their $1,200.